everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In last class, we completed our discussion on positive clampers. In this class, we will study negative clamper. So, this is the basic structure, circuit structure of a negative clamper. In this, we are applying square wave as an input signal. So, this is our input signal. Let's say it is varying from 0 to plus Vm to 0 to minus Vm. Now we will discuss what we will get at it output voltage. See, if we consider the positive half or this one 0 to Vm, the polarities will be like this and diode is connected in this manner, so polarity will be like this. So in positive half, this diode due to this positive battery, the diode is working in forward bias. Yeah, because positive is connected to positive of the diode, positive of battery connected to positive of diode, it means diode working in forward bias. If diode is working in forward bias, it means it is behaving like a short circuit. Why so? Because diode is providing very low resistance path. If it is providing very low resistance path, it means all current flowing in the circuit go towards the diode but not go towards the resistor RL, because all current is consumed by the diode and now this current is flowing in this loop. So at output what we will get nothing in positive half, but the current is flowing in this loop, so this capacitor will charge. Okay, so in first positive half cycle this capacitor will charge. Now we will consider what is happening in negative half. So in negative half, polarities are like this and this. Now this capacitor also charged from the positive half cycle, so polarity across the capacitor will also generate, and these are the polarity of diode. So we can see that Vi and C, both the capacitor voltage and the input voltage, they both are making the diode working in reverse bias. Why so? Because this negative of the battery is nothing but connected to positive of capacitor, and this negative of the capacitor is connected to positive of the diode. So these both battery making this diode working in reverse bias condition. If they making diode working in reverse bias condition, so what is happen? In reverse bias condition, it will work as an open circuit and no current will flow towards this diode. It means whatever the current flowing in the circuit will go towards the resistor RL, or we will get something at the output. So what we will get at the output? We will get the input voltage plus the capacitor voltage at the output. Okay. If we consider this Vm is similar to Vi is similar to Vm, why so? Because this input voltage fully charged the capacitor. So this Vm and Vi are similar to each other. So we can consider this V naught is nothing but 2 Vm. But with the negative polarity, because we are considering the case of negative half cycle here. Clear? So now in negative half cycle, this will go towards minus 2 Vm. Clear? This is the case of negative half cycle. So in between here somewhere minus Vm, and here it will go till minus 2 Vm. Now what will happen in third cycle or second positive cycle? Okay. Now what will happen in second positive cycle? So let us see, again discuss the polarity. This is positive, this is negative. Now this capacitor is empty. Why so? Because it's already give its charge to this. This is 2 Vm. So it is empty now, empty capacitor. Now if this capacitor is empty and diode due to this due to this positive half working in forward bias, so this capacitor is again charged and we will get nothing at the positive half. Yeah. So again the similar process, if we consider the second negative half, again this thing will happen and this will go towards the 2 Vm and this will continue. So in this diagram, what we can figure out that this Vm level shifted downwards to 0. It means if positive level was Vm earlier, now Vm shifted to 0. It means we shifted the DC level downwards. So this is the negative clamping. We shift the whole signal to downwards or the negative side of our graph. So this is the negative clamper doing here. Now we will discuss the biased negative clamper. So what is the need of biasing? We use biasing so that we can manipulate the output according to our need. Let's suppose we don't want 0, the reference level. We want some positive voltage at the reference level, but not Vm. or not the higher voltage, but some reference level we want. So what we will do, we just put a battery of that, we just put a battery of that voltage. If suppose, as an example, you can say, if a signal which is from plus 10 to minus 10 volt, okay, and if you don't want it in negative clamping, you don't want that it will start from 0 volt, but you want it will start from 2 volt or either from 3 volt. So what you imagine that it can start from 3 volt or either 2 volt or whatever you want. So what you will do, you will put a 3 volt battery with this circuit. Okay, so you are shifting the shifting the DC level at 3 volt now. Now the 0 reference level is not here, the DC voltage shifted towards the 3 volt. So we use the battery, simple battery here, biasing battery here, so that we shift the level according to our need. We are manipulating the output DC level according to our need. So let us discuss what is happening in biased clamper circuit. So this is the input, square wave, 0 to Vi, minus Vi. Now positive half, negative half. Okay. What is happening in positive half? Polarity are like that, like that. So what is happening in positive half? The diode is working in forward bias, but due to this VB, the diode is work as reverse bias because the positive terminal of the VB connected to negative of the diode. So due to this VB battery, the diode will work in reverse bias. We can similarly clearly say that if Vi or input voltage is smaller than VB, then diode work in reverse bias. If Vi or input voltage greater than VB, then diode work in forward bias. So in positive half cycle, the both condition are applying. Clearly? So what happened? In this positive half, due to this VB battery, diodes working in reverse bias, and in reverse bias it will work as an open circuit. So if it is working in open circuit, but we will get it RF, we will nothing get, but we will get VB as an output here. Because due to this VB, the diode is working in reverse bias, so we will not get 0 here, but we will get VB at the output. And similarly, if the diode become forward bias, it will do nothing but charge this capacitor in the positive half. What is happening in negative half? So in negative half, this is the polarity, minus, plus, and this capacitor is already charged from positive cycle. So these are the polarity of capacitor and this is the polarity of the diode. So in this case, what is happening? This battery and this capacitor voltage, they both are making reverse bias to the diode. Why so? Because negative of battery is connected to positive of the capacitor. So it means they both are adding. And this negative of the capacitor connected to positive of the diode, it means they both battery, which is nothing but minus 2 Vm we can say. Because in negative half, we are considering Vi plus Vm and they both are in negative half cycle, so a negative sign will be there, and we consider Vi similar to Vm, so this is nothing but 2 Vm, as we earlier see that this is nothing but 2 Vm with a sign of negative voltage here. So what is happening? This 2 Vm is making this diode working in reverse bias, but this VB is not negative. It is not negative. It is the polarity of EB is not changed because it is the biased battery. It will always work as positive bias. So output what we will get minus 2 Vm plus VB. Clear? So this is the output of the negative half. So it will go till not till minus 2 Vm but minus 2 Vm plus VB. Okay, whatever the voltage is, it is going till minus 2 Vm plus VB. So similarly, what will happen? Similarly, what will happen? We will consider for negative next positive half cycle. What will happen in next positive half cycle? Similarly, in next positive half cycle, what is happening? These are the polarity plus minus, and this capacitor is discharged because we are considering the capacitor voltage here. So it is discharged plus minus. So again the two condition will follow. If Vi is smaller than VB, diode work reverse bias and we will get nothing but VB at output, and if diode work in Vi greater than VB work in forward bias, it means it will charge the capacitor. So in second positive half cycle we will get VB as an output, and similarly it will increase like that. Okay, the output increase like that. So is this what we can see? We see that we shifted the DC level not to 0 but to a particular voltage VB. Clear? So this is the need of biasing, that we are modulating, we are manipulating the DC level according to our need. If we want our level from, let's say what will be, let's say this VB is of 2 volt and the input is of 5 volt. Clear? Input is of 5 volt and this VB is of 2 volt. So what we are doing? We are shifting it from 2 volt to 5 plus 5 minus 2. It means 10 minus 2, which is nothing but 8 volt. So it is going from 2 volt to 8 volt. Earlier, if it is 5 volt, it is going from plus 5 to minus 5. Now output will go from go from 2 volt to 8 volt. Okay. So this is the whole of negative biasing circuit here. We in this class we discuss negative clamper circuit and negative biased clamper circuit. So I think they both clear to you all. If you have any query, you can write it in comment section. I will try to clear this, or numerical based on this topic we will start shortly. Okay. Thanks for the class.